So a lot of people had asked about the ON HDS2 whatever. So I thought rather than try to just take pictures of it, because a lot of the both pluses and minuses of this thing have to do with seeing it in action, I thought I would at least get a short video. So it comes in a relatively nice case like this. Everything kind of fits. It comes with a full array of stuff. It actually does come, I didn't think it did at first, but it does come with one of your cheapy probes. I had to get the 40 megahertz version, and it came with a cheapy 60 megahertz probe. There you go, focus. Yeah, apologies for the lighting and everything, but I don't often record stuff in video, so. The thing itself feels nice and sturdy. It's got sort of your standard rubber overmolding, and it actually does go all the way through. So when I take it apart and so you can see the inside, you'll see that it actually does go through the entire plastic case. So it does feel quality, like you're not going to peel this off. There's no way. Well, unless you're doing a lot worse with it than I am. As for the device itself, get that centered enough. It comes on plenty fast. You can hear a relay clicking in there. It does have an actual honest-to-God physical relay in there too. So, I guess I'll start with the downside. Honestly, I'm a pessimist kind of guy. I will say that the meter part of it seems to go. It's plenty snappy. It's not as bad as you would think, or you could be afraid of. At least in terms of how quickly it moves. It does have one of the sort of latching continuity tests, so you can see that it's not that hard to go fast enough. But I know that sometimes this is the probe, but because it is that latching type, yeah, it's not going to win any speed records there. I would not get it for its continuity testing, we'll put it that way. No, the real bummer, and the thing that I cannot quite get over, is this. Watch the range up there. See, right now we're at 100 megs, right? I'm going to short the leads here and count how long it's going to take. Okay, so you can see that we're taking like a good 4 seconds just to range down from 100 meg. I can't get over that. It's just, this is easily the worst thing I found so far. Almost everything else about this is actually really nice, but the ranging speed is abysmal. And it's not just for the resistance. Let me grab a... And you can see how utterly prepared I am. Had a crappy old laptop 18650 I was going to try. Of course, I have no idea how much voltage is in here, but we'll see. Well, that's not... Yeah, there we go. Okay, so you see, even though we're just going for voltage, right? The standard range is 2 volts, so when I do this, it briefly jumps to the 1000 volt range, then decides, oh, maybe this isn't 1000 volts, because I don't know how often other people test for stuff like that, but it's just the ranging is just anemic, and anemic's not the right word, glacial, we'll put it that way, and it drives me crazy that you can, like, this would be much better, if they skip the 2 volt range entirely, or you can see they do have a setting here for volts and millivolts. So they have a 200 millivolt range. So why not just make that the default if you need something small and use the default to 20? That at least would make sense, because then you'd have a decent range to start off with, and you wouldn't need to go through this. If we do something like this, like a little button cell, you can see that the actual speed of measurement is not bad at all, and the refresh is real good. It only takes about, 3 or 4 readings before it's right up there, and I don't know, I would say that that's less than a second. So that's not the fastest I've ever seen, but it's not bad. And so you've got a decent measuring, and yeah, you got good repeatability here. It's really not bad at all, except for the fact that, I mean, the ranging is so bad. And keep in mind, this is not for like a crazy high energy battery. This is a dead laptop battery cell. This is, let's get a good connection here. Of course, he says that and doesn't get a good connection. There we go. See, like, we're flirting with that 2-volt thing at the beginning, and it's fine. But then, of course, once it gets up to the 2 volts, which is barely over, it immediately has to take 10 seconds to flip to, well, not 10 seconds, but you know what I mean, to flip up to 1,000 volts for no reason, then back to 20. So, I don't know, that's kind of stupid. That if they're paying attention and knew that their auto ranging was just this bad, started at a better range. Because yeah, if you flip it to the manual range, which of course has a nice range button here, you can manually set it to 20 volts and then it's no problem. Then you can just go here and here. Or you can if I'm actually any good. I know, you take off the stupid protectors, right? Yeah, this is my incompetence. It's not the meter's fault. There we go. Like I said, so if it's on a manual range, you can manually set it to 20 volts, and then it's totally fine. And then you can measure, honestly, for me, what am I going to measure that's over 20 volts or needs, what, 100 microvolt precision? The answer is nothing. Nothing. 0 things. So, honestly, leaving it at 20 volts is fine. And as far as this, you can see, unfortunately, it switches it right back to auto as soon as you're off the voltage range. And if I switch it to manual, I'm willing to bet if I turn it off and turn it back on, it's going to be right back at auto. There you go. Right? I'm not sure why it didn't start up in millivolts, but yeah. So I would say easily the meter part of this, that's the worst, is the range, the auto range speed. I mean, compared to my other multimeters, it's terrible. Compare it to like this one. Same leads even. And go. Okay. Okay, now I'm again doing a terrible job of this, but there. Okay. That's how fast I think auto ranging ought to work. It's that fast. And again, fine. You know what? I am going to take off these things because they're making this all take too long. Okay. Okay. That isn't even that great, I'm sure, for people with like expensive meters, but that's how long it should take to go through ranges. And then once again, you go into this guy, and 10 years later, you actually have a reasonable reading. I swear it can't change ranges faster than like 1 per second. And then the other one, which is the Unity UT61E, no problems. Just blazes right through them. I haven't got time for that stuff, which I appreciate, to be honest. Okay, but other than that, it's perfectly competent. I haven't seen anything. I would do any sort of accuracy thing, but I don't think it's worth it, personally. It seems fine, like accuracy-wise, and certainly it's got a 2 what, 20,000 count multimeter, but at the same time, I would rather it was 9,999 and didn't need a range as often. But that's just me. I think that from what I've seen when I was looking for a multimeter the first time, ON has this problem with their um, multimeters, and if they know that, they should try to, use a little bit of forethought and program around it. But that's just me. Whatever. Don't want to hear a complete novice talk about this. So let's go on. There is also a function generator. That in mind, I figure probably you can take these leads off, set them aside. I'll start with these guys. So it does come with two sets of these BNC to alligator things. And there are the three, lighting wise, three connectors up here. There's channel 1, channel 2, and the signal generator, which is this one right here. So, in general, the interface is still pretty good, and it doesn't take that long to move about. You can see that if I want to set, like there we go, 5 megahertz sine wave or 5.5 megahertz sine wave. It's relatively intuitive, or at least it didn't take me that long to figure it out. So again, the settings here are reasonably, well, apparently I can't get an offset that high. Well, no, fair enough. I guess that's probably 50% offset. As for accuracy, figure the only thing I really have that can display this isn't going to be very good for it. Give it a shot. Sorry. Kind of dwarfs this thing. Although this does put into effect, when we talk later about the oscilloscope, why it's nice that this thing is a thing. I guess if I'm going to do that, though, it would make more sense. And somebody can yell at me if I'm doing something about impedance mismatching or something by just not having a 50 ohm terminator. See if I can do something about that glare here in a second, too. So I think these are not the world's best. Apparently, super phosphor, a little too super for a. So. Again, apologies, but it'll have to be good enough for now. So you see we're not doing anything, and then, ta-da! I should try to use this thing. Okay, and yeah, it looks like we're it's still got it in times 10 mode. That's why. I said total novice. Sorry. Okay. So yeah, it looks like this is claiming we have a 2.38 volt that goes from what, negative 1.2 to positive 1.16. So considering I set it here to a 2.5 with an offset of minus 1.25, I mean, that's fine. And the waveform settings, such as they are, we've got the usual suspects, sine. This is the square wave, which I thought was kind of crazy, but then the max on this is supposed to be 5 megahertz, and that's what it's running at. It's still not what I would consider like flawless, but from a rise time perspective, it's If you exclude that little dip there, looks like it's about, delta x is 42 nanoseconds there, so that's, I don't know, you can decide for yourself what that might be. This is, by the way, a Siglent 100, well, it says up there, but 100 megahertz 4-channel scope. So then we also have this little dip here. In some of the other things, it looked a little bit like ringing. So like some of the other, like the triangle, you can see it's got this little, but it has that little notch there. Turn the cursors off. So, I mean, it looks like the from a function generator perspective, it's okay. That might also be, again, because I'm not doing any kind of, this is just connecting straight with a BNC cable, so somebody who knows more than me can answer that question. But yeah, we've got all the usual suspects here and a general array of our sort of interesting kinds of waveforms. It looks like we can do all kinds of fun arbitrary-ish waveforms, like a stair step. Let me actually kind of trigger in a reasonable place. He says triggering at a non-reasonable place. So yeah, it looks like we've got, you know, a fair array of stuff. Most of these can go from 0 to 5 megahertz. The sine can go, I think, to 25. But you know, for whatever that's worth, I don't have any intention of needing. I use the pulse at 50 hertz to drive a standard PWM ESC for the students in class. Worked fine. I have really let's say modest ambition with it. So, but yeah, you can put the sine wave up to something way faster than you probably need it to go ever if you're going to actually use this for driving a thing. And you can see it's fine. It's fine. I mean, for a 25 megahertz waveform, it doesn't look too bad. And it looks like we're supposed to be at 2.5 peak to peak. And we're down to about 1.8, 1.9. But I mean, if you pull that off just a tiny little bit to 22 megahertz, oh, the horror. You know, you can see by the time we get to 20 megahertz, we're actually back up at 2.5 volts. There is a little bit of weird sort of like overshoot here. I don't know if that's resonance or whatever, but like I said, all the way at 25 megahertz, which is the absolute max it's supposed to be at, we're still getting almost 2 volts. So take that for what you will. Right. You can also turn it on and off, but one of the things I actually really like about this, and I'll show you just quickly, is if you turn this to another mode, the function generator keeps going. It doesn't actually change. So you can run the function generator in the background while this is running, which I thought was kind of handy. So you could be measuring something with this while actually running the function generator, which is nice. Yeah, so I guess let me take a second here, put away this guy, and look at the actual oscilloscope itself. So I'm going to actually just, because why not? I have a cute little function generator there. That's so into the oscilloscope. This is, as far as I can tell, it's not some like the toy oscilloscopes I've seen with a lot of other sort of handheld things. This does seem to have the proper functionality of one. You know, most of the stuff is done with these function buttons, but we do have enough controls to actually make it not that hard to navigate. We've got our channel selector. This is when you make changes to the horizontal, to the time base. That's right there. There's measurements that you can bring up. Cursors also here. All of which is fine. And you can see that this actually does work relatively speedy. It's not that bad. Which I've actually been really honestly pretty impressed with. And I don't know, maybe that sounds like a bad thing, but I actually think the scope is nice. It's a little bit bigger than the Handtech one that I was looking at before I noticed that this one was a thing. And so the information that you can hold on screen actually is not too bad. So if we put all that stuff in, what do we got here? So it looks like we've got frequency, period, amplitude, min-max, peak-to-peak, mean, all kinds of fun stuff here. And unlike the Siglant, which still drives me crazy to this day, you can actually have, it looks like 6 things on there instead of the Siglant's 4. So